So the second last logical connective is what we call the conditional. Conditional is also called implication. So the term implication and conditional mean the same thing. And we use this notation for conditional. We use this notation, an arrow, or we write this. So as usual, we start by definition, give examples, and draw the truth table. So let P and Q be two statements is then the implication of the conditional of P and Q denoted by or this way is a statement if P, then Q. So this is how we define the implication of the conditional of P and Q. If P, then Q. And then what not? When we write P is called the hypothesis Eastern. The hypothesis or antecedent, and Q is called the conclusion or the consequence. So when we write this one, the first statement is called the hypothesis, while the second statement is called the conclusion. So that should be very clear from the start. And this simply means if P, then Q. So for example, if I have a statement A, it is raining. I have a statement B, today is Monday. I have a statement C, 4 plus 6 equals to 10. I have a statement D, tomorrow is my birthday. I have a statement D, Nairobi is the capital city of Uganda. So consider these 5 statements. Then if I write this, then this statement means, is there anyone who can tell us before I give the answer from the definition?
If it is raining, then today is Monday.
Correct. If it is raining, then today is Monday. Good. Then what would be the meaning of this statement? This will mean? Correct. If today is Monday, comma, then 4 plus 6 equals to 10. Please note that these things may not be making any sense in English, but what we care is the logical connective we are discussing. And then 3, what will be the meaning of this statement? Correct. If tomorrow is my birthday, then Nairobi is the capital city of Uganda. Good. So note the statement also means P implies Q. P only if Q. Then we can also have P is a sufficient condition for Q, or Q is a necessary condition for P. So if we are to use the first one, the first definition of this, P implies Q. So for example, here, when we write this, we'll say it is raining implies today is Monday. We'll have the same interpretation. Then truth table. So the analogy we use here is a promise. For example, your guardian can tell you if you score an A, yeah. If you score an A in mathematics, so, if you score an A in mathematics, then I'll buy you a laptop. Then I'll buy you a laptop. So we draw this P, Q, P implies Q. So true, true, false, false, true, false, true, false. So this is how we interpret this analogy. So there are two things here. One is about the score in mathematics, so which will be the statement P, and the other one is being given or bought a laptop, which is statement Q. So this is how we interpret the table here. When I have T under P, we mean that you have scored an A in math. If I have F under P, it means you didn't score an A in math. Then under Q, if I have T, then it means you are given or you are bought a laptop. If we have F under Q, it means you are not given or you are not bought a laptop. Then the result we write as our final answers. There are two things. We will put T if the promise is not broken. And we'll put an F when the promise is broken. And then if we assume that U refers to you as a student, then when do you have a valid case against your parent if they tell you that they will in math? What are the valid cases whereby you'll accuse them of having broken the promise? Which scenario or which scenarios will make you have a case against the person making this promise? Yeah, that's the only valid case you'll have against your parent, someone who sells this. But if you don't get an A and they don't give you a laptop, do you have any grounds to argue or to say that you are treated unfairly? No. So then now, let's interpret this. So what would be the meaning of the first line? Is there a problem? No. So that's a good case scenario. All of you win. So you put T. Second line means So is there a valid case against the person making the promise? Yeah, so here, the promise has been broken. You have done what they told you to do, and they have not honored their promise. So therefore, we put an F here. In the third line, what does it mean? Is there a problem to you as a student? Will you make any noise against the person doing that? Unless you are abnormal. So there's no problem here. This will still enjoy life. And then last line means can you make any case against the person? No, there's no problem there. So this is T. So know the difference between this table and what you have filled earlier on. That if is turning out to be T, that you didn't get an A and your parent didn't give you a laptop. So you don't have any case against your parent to say that they have broken the promise. You didn't do what they told you to do, so there'll be no mistake. There'll be no crime they'll have committed for them not buying your laptop because you also didn't do your part. So that's the final table. So then summary, NB, an implication is only false when the hypothesis is true, but the conclusion is false. Otherwise, true. But we are saying when someone promises to give you a present and they tell you to do something, if you do that something they have told you to do and they fail to give you a promise, then they have broken the promise. So there's a case against them. But in all other cases, there's nothing that we can argue about. The only time we'll have a case against the person making the promise is when we have fulfilled what they told us to do, but they fail to do what they say they'll do at the end of the exercise. So that's the verdict we make there. Lastly, biconditional. So biconditional, we use this or this notation. So if we have two statements, so we have two statements, P and Q. The biconditional of P and Q denoted by we have double arrows. In a statement, P if and only if Q. So that's the meaning of that statement. P if and only if Q. So for example, if I have P At the statement, it is raining. And I have a statement Q. Today is Monday. Then this will mean it is raining if and only if today is Monday. So that's the meaning of that. So other meaning of this statement. We say P is equivalent to Q. Or we can say P is a necessary and sufficient condition for Q. So that's what we have. The truth value for this one is very direct. The truth table. So when we have, as usual, we'll have 4 rows. So P, Q, P if and only if Q. 1, 2, 3, 4. So true, true, false, false, true, false, true, false. So here, P if and only if Q means that the result will be true when the truth value of the first statement P and the truth value of the second statement Q are identical. So therefore, this will be true, this will be true, but these other ones will be false. And then the note NB we put here is that the biconditional is only true when the two statements, or when both statements have identical truth values. Otherwise, false. That the truth value of a biconditional will be T when both statements are true or both statements are false. But when we have opposite truth values, then we get a false value. So that's where we stop. Now, next time we'll be discussing how we connect different logical connectives to form compound statements. Have a good day.